Hi guys, so today we're going to briefly discuss a little bit the relationship between exponential and logarithms. The relationship is that they are inverses of one another, and we did inverses, huh? Yes. Did we? Yes, we did. Remember when we did inverses, if we had like y equals x plus 2, we would then swap our x and our y, and we would solve for y. And remember, like this was like f of x equals x plus 2, and this was f inverse of x equals x minus 2. Remember that? Okay, yeah. We learned it earlier in the year, but that's, if you don't, it's okay. You don't have to necessarily really remember it. We're going to look at it graphically next week, and it'll help you. It may recharge some of your memory. But the relationship is that they're inverses, and what this means is that we can use exponentials to help us solve logarithms, and we can use logarithms to help us solve exponentials. And really, that's going to become, in 2 weeks maybe, it's going to become very necessary that we know how to go back and forth between these two types of functions. If not, we're not going to be able to solve equations. So if we want to, so we can take a log and we can turn it into an exponential. So if we know that the base to the power equals whatever you're taking the log of, okay, if we were in class, I would have you write this on a note card. So maybe that's a good idea, even for you to do it anyway, or make note of it. So when you do a quiz at the end of the week, you can have it just jotted down for you. But oh, there's a warning going off on my phone. How lovely. Yeah, guys, I'm making this at Sunday night at 8:06 because that's how far behind I've been running. But the base to the power equals whatever you're taking the log of. If we were in class, you would hear me say the base to the power equals whatever you're taking the log of. The base to the power equals whatever you're taking the log of. And I would walk around the room and chant it like on the proposal whenever they're at the fire. And Sandra Bullock and Betty White are going around the fire and they're chanting. Yeah, that's how I would chant it. But y'all don't, I'm sorry, you don't get that joy of hearing me chant. So the question is, what is our base? In this case, our base is b. And our base and our log function and our base and our exponential function are the same. Okay, so it's going to become your b. So the base to the power equals whatever you're taking the log of. So we're taking the log of x. So we have to say equals x. But the thing is we have to raise b to something. That's the whole entire point of an exponential function, is you have to put a variable up there in b. And so the answer to the log problem is the exponent. So here our answer is y, because it says equals y, right? So that's why y is our exponent. So you would hear me say the base to the power equals whatever you're taking the log of. The base to the power equals whatever you're taking the log of. And then I would say the answer to the log problem is the exponent. The answer to the log problem is the exponent. The answer to the log problem is the exponent. The answer to the log problem, see how it says equals y, is in our exponent. Now, today we're really going to be focusing on going from a log to an exponential. But in the future, we're going to also go backwards the other way too. Okay, so let's look at these and notice and see if we notice any powers. The first one, we have log base 25 equals 2. We've already looked at this one before. We know it's true. What can we raise 5 to equal 25? 2, right? So guess what? 5 squared equals 25. 5 was our base. It became our base here, right? Okay. Log base 16. Our base is our base. What can we raise 16 to equal 4? So what can we do to 16 to equal 4? Our answer would really be 1/2. We're not actually solving it right now, though. And then log base x of 8 equals 3. So let's look at this a little bit more cleanly where I wrote it out in our notes. Our bases all become our base. Now, let me change my colors real fast. Some of my students really like to draw arrows. So you would say here to here. Okay? That's the reason why I don't have anything. You won't see anything pop up on this bottom, like this log base x of 8, because I'm going to show you some of the arrows that people like to draw. But we notice our bases stay our bases. Whether they're the base of our log or the base of our exponential, the base is the base is the base is the base. That's all there is to it. Now, what you're taking the log of, if it's on the right side of the equal sign, where did it go to? The left side of the equal sign. If it's on the right side of the equal sign, like both of these, see how 25's on the left and then 25's on the right? 4's on the left and 4's on the right. So they're swapping sides. So if 8 was over here on the left, I had to take 8 over here and to put it to the right. Now let me write my arrows back. Then our 2 was on the right and it moved to the left. 2 was on the right, it moved to the left. X was on the right, it moved to the left. So this has to switch sides, okay? So our equations are never going to equal the same thing. I thought I had a thing that said that. So they're never going to equal the same thing. Another conclusion that you could draw is that the base is the only thing that stays in the same place. So if you look at like log base 5 of 25, like the 5 and the 25 were paired together. So when it switched to an exponential, the 25 couldn't be with the 5 anymore. Okay? So the other two things swap places. Like, I don't know if that really makes any sense. But last semester, the biggest thing that we had success with was the answers. Like, if it equals 2, like if this equals 2, it cannot equal 2 over here. It has to equal the other number. So maybe that'll help you. In Google Classroom, I'm going to have a PDF of some sample problems that you can work out. And then if you can, like on page 1, and then if you scroll on page 2, you'll see where I worked them out. And my suggestion to you, because this is such a key concept, my suggestion to you is that you don't just look at the answers, like actually try and see if you can do it. So like if I tell you log base x of 3 equals 8. Oh, that's the one we just did. Okay, log base x of 2 equals 49. Crap, that's wrong. This is why I make up problems ahead of time, guys. Log base x of 49 equals 2. Okay, so my question is, in this problem, what is the base? X. Very good. X is the base. Okay. What is paired with the base right now? 49. What is the log equal right now? 2. So we know down here in this exponential function, 49 cannot be paired with x, and it cannot equal 2. That means it has to equal 49, and then 2 has to be paired with x. And your variables can be in any spot, no matter what. So here, what is the base of the problem I just wrote? 9, right? Because we would read that log base 9. 9 is always this little number written at the bottom. Log base 9 of 3 equals x. Now here's my question to you. What does the log problem already equal? It already equals x, right? So it can't equal x. What is the only other number that it can equal? 3, right. So where's the only spot still open? X. Very good. Let's do one more. And by the way, x equals 1/2 because the square root of 9 equals 3, right? Okay, this answer is 7 because 7 squared equals 49, right? Let me see, which problem do I want to make up? Log base. Okay. What is the base of the log I just wrote? Is there a base written? No. So what base is understood? 10. Very good. except I messed it up. I messed it up again. I'm going to rewrite it. Log okay, so same thing, I just have to swap it. There's no base written, so I understand that the base is 10. What is, so I could write a 10 here if I needed to. What is touching the 10? What is paired with the 10? 100. So that means 100 cannot be paired with 10. What's the only other number that can be paired with 10? X. So what is the only other spot that 100 can go to? Here, right? And what can we raise 10 to equal 100? 2. Okay? So that's this whole lesson. If you need to go back and watch it again, you can. And look at those extra problems and check it out.